Okay, now for this question, mass. Mass is given to me how much? This is the mass of the van. The mass is given 2200 kilogram. That's the mass of the van is given to me. It's parked on a road that has incline of angle 20 degrees. Let me write it as angle of theta. The theta represents the angle. Let's say that is 20 degrees above the horizontal. And we have to find what? Magnitude of normal force. Let me say normal force is N. Let me say N represents the normal force. And static frictional force. Let me say static frictional force is F of S as a static frictional force. This is what we're going to get from the question. Other than that, nothing is given. Okay, let me go and try to make a figure. Always in physics, figure matters. Let me say this is a surface. This is a surface. And what I saw is that your road is at an angle of 20 degrees above the horizontal. Let's say this is a horizontal surface. Is it? Okay, that's more than 20 degrees. Let me say this is like around 20 degrees. Let's say this is a, okay, let me write theta instead of this. Okay, this road is at angle of 20, at angle of theta, because the theta is 20 degrees, we know that. Let me say my block is here. This block represents your van. Now, whenever your block, it's not only block, whenever anybody is at like this slanted road or the road that is making a certain angle, you have to do a rectangular components of vector, a lot of rectangular components. We'll figure that out. At first, we know that always your weight is acting always towards the down. Always your weight is acting towards the down. Normal force is always acting perpendicular to the surface. Always perpendicular to the surface. Okay. Now, this is what normal force is. Now, what's happened is that your weight is making some angle with the perpendicular, is making some angle to the parallel of the normal force. We can say to the parallel of the normal force, because this blue line represents what? That blue line is the parallel to normal force, and your weight is literally acting what? It's making some angle to the normal force. To the parallel of normal force, you can say. Let's say that angle is what we call theta, and this is the same theta. Okay, I should have to select, but those two are the same angle. Now what does that blue line, this blue, if I do the rectangular components of that weight vector, I can say that this blue line represents your what? Cosine of it. And now there is another force who is going towards this, if I do the rectangular components, that is one of the forces going in that direction. That force is equal to what? Weight of sine theta. At first, we have to understand this thing. If we understand this graph, then that's fine. Now, here is one more thing. Your car is moving where? Your car, now when the car starts to move, your car is moving in this direction, yes? It's going down towards the road, isn't it? When your car is going, it starts to move down towards the road. When there is a motion, there is a frictional force. That means what we can say, this is the direction of your frictional force. This is the direction of your, let me write right now as my frictional force. Okay, now we got everything else. Let me go and try to solve the question. Now this is what the graph looks like. This is what the pictures looks like. Whenever we know all the information, whenever we get all the information from the graph, now we can go and do something. Now your normal force that is acting perpendicular to the surface, your normal force is balanced. That's normal force is your vertical force. That is balanced by what? That is balanced by your W cosine theta. Because both of them are acting in vertical direction, and both of them are in parallel with an opposite direction. That's why they're gonna be same. Now your normal force will be equal to what? This weight of your van. Weight of your van is always equal to what? M times G cosine of theta. Now we know the mass. What is the mass? Mass is given to us. Mass is given to us like 2200. That's the mass of the van. That is 2200 mass. That's the mass of the van. multiplied by acceleration due to gravity of the block constant 9.8 meter per second square times cosine of theta. What's the theta value given to us? The value of theta given to us is how much? 20 degree.
Yep.
Let me write that 20 degree here. Okay, let me go and try to solve this question in my calculator. I got 2200 multiplied by 9.8 multiplied by cosine of 20 degree. Whenever I got that, I got a very large number, a large value of around 20,259.7 Newton.
Yeah.
Let me write. Okay, this now both of them looks n. Okay, but it's fine. It's fine. No worry. This is what the normal force is, and don't get confused here. Here also you see n, here also you see n. This n represents the symbol for normal force. This n represents the symbol for Newton.
Got it.
That's the thing you have to know. Now we got this as what? This is your normal force. The question is asking what? Coefficient of normal force on the car. That's the answer for that coefficient of normal force. Now, since we got that, this is the answer for part A. Now we have to go and solve for another thing. Another thing asking to us is what? Magnitude of static friction. Whenever the question says static friction means what? This is the friction exerting on the car when the car is not moving. Or this is the friction that is in the car when the car is not moving. For that, what happens? When your car is not moving, what should happen? When your car was moving, your car will move towards this, towards the downside.
Yeah.
But when your car is not moving means what? The force that is acting in this direction is balanced by the force that is acting in this direction. That is balance. Whenever I say balance means what? Their difference is equal to 0. That's what their sum is equal to 0, you can say. And if I do the sum means that also given the same meaning to us. F plus W sine theta, will that be equal to 0? Means we can say F is equal to minus W sine theta. This minus represents, it's not the value, minus represents your direction. Minus represents what? Direction. That is your direction of the friction is in the opposite to the direction of W sine theta. That's what information we can get from here also. From here also, your frictional force is acting towards the left and your W sine theta is acting towards the right. It's totally acting in opposite direction. That's what the meaning of W sine theta is there. But no need to go over this one. I didn't want to make you confused. What we can say here is that since your van is not moving in a static condition, that is the question is asking static friction exerting on the tire, we can say that is equal to what? Frictional force that is equal to the W sine theta. Now this frictional force is same as what? This frictional force during the static condition, we can write it as what? F of S. That's what the symbol I have used earlier. Here, that's what the symbol, oh sorry, that's what the symbol I used here. You see F of S. F of S represents the frictional force during the static condition, or static frictional force, we can say it like that. That is now equal to what? That is now equal to W is the weight. Weight is equal to mass times acceleration due to gravity times W sine theta. We can write it as the mass of the van is 2200. Oh, sorry, 2200.
Yeah.
It's 2200 kilogram multiplied by 9.8 meter per second square times sine of an angle of 20 degree. Okay, let me do that. 2200 multiplied by 9.8 multiplied by sine of 20 degree. This value should be lower than earlier. 7,373.9 Newton. That is the static frictional force. That's the static frictional force that the ground exerts on the tire of the block. Okay, yep. That's our answer.